We're going to talk about comparative advantage, specialization, and trade. This is a topic that's on both the micro and macro AP exams, so it's an important topic that we will practice in both courses. We'll take an example of the United States and Japan. In this example, we have amounts of cars and computers they can produce in 8 hours. So you have to identify what is varying here, outputs or input. The input is the same, 8 hours of work. The output is what varies, the number of cars or computers. So here, the outputs vary. As you can see, the U.S. produces 200 computers in 8 hours, Japan 100, and the U.S. produces 40 cars in 8 hours, and Japan produces 50. From this data, we're going to draw the production possibility frontier for both the U.S. and Japan. So the production possibility frontier for the U.S., we have cars and computers on the y-axis, and we will say here that if the U.S. totally specializes in computers, they can produce 200, so that puts us at that data point. And then for cars, they totally specialize in cars, they produce 40 cars. We're going to say the production possibility frontier is constant. It's a constant trade-off. We know usually that it's not at higher levels of production. It's just, there's a greater opportunity cost, but for the sake of this example, we'll draw our production possibility frontier as a straight line. And now we'll do Japan's production possibility frontier. Same thing, cars on the x-axis and computers on the y-axis. And we're going to do a little bit different scale on this. We're going to say Japan is at 100 here, 100 computers, and we've got 50 cars on the x-axis, and we would draw our production possibility frontier for Japan. Okay, we'll come back to the production possibility frontier. We'll show you how this changes when there is trade. So we need to define a term, absolute advantage. Absolute advantage is the comparison of productivity of one person, firm, or nation to that of another. Here we're comparing two nations, the U.S. and Japan. The U.S. has the absolute advantage in computers. They can flat out produce more computers in 8 hours than Japan can, 200 to 100. Japan has it in cars. Japan can produce 50 cars, the U.S. 40. So each country in this example has an absolute advantage in one of the goods. A country can have the absolute advantage in both goods. If you're comparing the U.S. to some small country like Switzerland or something, then the U.S. probably has the absolute advantage in both cars and computers compared to Switzerland, just because they're just a much bigger country with more resources. So it's possible to have the absolute advantage in both goods. As we stated, okay, so now we're going to do comparative advantage. With comparative advantage, let's see if I skipped. Comparative advantage, we consider the opportunity cost with 8 hours of production. So to figure out the opportunity cost, when outputs vary, the good you're finding the opportunity cost of goes in the denominator. So when we do the opportunity cost of one computer, we're going to take, for the U.S., 40 cars divided by 200 computers. Computers is what we divide by to find its opportunity cost when outputs vary. So 40 divided by 200 is 1/5 of a car. The cost of a car for the U.S., opportunity cost for a car, is just going to be the inverse of that, because we're taking 200 divided by 40. So it's always the inverse of one good is always the inverse of the other. For Japan, our opportunity cost of one computer is 50 divided by 100, or 1/2 of a car, which is 2 computers. So the U.S. has a lower opportunity cost of producing computers, 1/5 to 1/2. Japan has the lower opportunity cost of producing cars, 2 versus 5. Comparative advantage is a comparison among producers of a good according to their opportunity cost. The country that has the lower opportunity cost in a good has the comparative advantage. So the U.S. had the comparative advantage in computers. Japan had it in cars. Each country will always have the comparative advantage in one good because you're inverting those values. If you have the lower value in one, when you invert it, you're going to have the higher value in the other good. So it's mathematically impossible to have comparative advantage in both goods. So trade with comparative advantage. Trade benefits all. Trade allows people to specialize in activities they have the comparative advantage in, or they have the lower opportunity cost. The U.S. had the comparative advantage in computers, so they will trade computers with Japan, export computers to Japan, and Japan has comparative advantage in cars, so they're going to trade the cars or export cars to the U.S. From this, we have to determine terms of trade. U.S. will trade one computer for 1/5 or more of a car, the U.S.'s opportunity cost of a car, but Japan is only willing to take one computer for 1/2 of a car. Okay, so and that's Japan's opportunity cost. So the terms of trade are going to be between the opportunity costs. They're going to trade. These two countries will both benefit from trade if when they trade one computer. The U.S. trades one computer with Japan. The U.S. Should receive back between 1/5 and 1/2 of a car. When Japan trades a car to the U.S., Japan will receive between 2 and 5 computers. As long as they stay within those terms of trade, both countries will benefit from the trade. So let's determine trade amounts when it's more than one item. The U.S. offers 100 computers to Japan. How many cars would they receive in return? We take the 100 computers and we multiply it times the opportunity cost. 100 computers times 1/5 equals 20 cars. And 100 times 1/2, Japan's opportunity cost, 50 cars. So the U.S. should expect to get between 20 and 50 cars in return. The U.S. must receive at least 20 cars to benefit from the trade, and the most Japan will give is 50 cars to benefit from the trade. So specialization, let's see what that looks like with these two countries. So for the U.S., we'll do an extreme example. The U.S. is only going to produce computers, and they produce 200. That's how much they can produce if they maximize the use of their resources, and no cars. Okay, Japan is going to produce no computers and 50 cars. So the U.S. will trade 100 computers to Japan, and we're going to say Japan gives the U.S. 25 cars in return. So the resulting amount of computers and cars that the U.S. has is 100 computers and 25 cars. With Japan, with this trade, okay, they're going to receive 100 computers, and they're going to, of the 50 cars they produce, they're going to trade 25 of them to the U.S. So the amount that the economy of Japan now has is 100 computers and 25 cars. So now let's go back to the PPF and look at how this trade has benefited both countries. So if we draw the production possibility frontiers again, we got the U.S. cars, computers, and we had 200 computers and 40 cars, and that was the original production possibility frontier. And now the U.S. is at 100 computers, so they're here, and 25 cars. So that puts the U.S., the new point would be somewhere out here past its original production possibility frontier. This is 125. So the U.S. has exceeded its production possibility frontier if it only was within its own economy by trading with Japan. Let's look at Japan's benefit. So we have the production possibility frontier for Japan. And now the Japan is at 100 cars and 25 computers. So as we can see, Japan really benefits from this trade agreement, all right? And they far exceed their original production possibility frontier. So this shows how trade can benefit when countries trade according to their comparative advantage. This trade will benefit both countries. Now we're going to do the analysis where the inputs vary. So the amount produced is the same. It's one of each, either good. One computer, one car. And what we have is the number of hours it takes them to produce that. So for the U.S., we're going to say it takes the U.S. to produce one computer takes 1 hour. It takes Japan 2 hours. For the U.S. to produce one car, it takes 5 hours. It takes Japan 4 hours. Okay, so we are going to look at the opportunity cost. Now, why we have to note whether inputs vary or outputs vary is you figure the opportunity cost differently. When inputs vary, you're going to take the opportunity cost of the good that you're finding goes in the numerator. So for U.S. now computers, we're going to take the one computer 1 hour and divide it by 5 hours. So that one computer's opportunity cost is 1/5 of a car. We invert that and it's 5 computers. For Japan, we're going to take the number of hours to produce a computer, put it in the numerator, 2, and divide it by the hours for produce a car, 4, and that gives us 1/2 car. And if we invert that, 1 car costs Japan 2 computers. So these opportunity costs are the same as when outputs vary by design. It doesn't matter whether you do inputs vary or outputs vary, you should have the same opportunity costs after you've done your analysis. So again, the country that has the lower opportunity cost has a comparative advantage. So the U.S. has it in computers, 1/5 to 1/2, and Japan has it in cars. That concludes our notes on comparative advantage, specialization, and trade.